History of Spatial Structures, a conversation with global leaders in the field. In August 2020, the University of Surrey will host its 7th International Conference on Spatial Structures, which will coincide with the 61st Annual Symposium of the International Association of Shell and Spatial Structures, IAS 2020. As Surrey prepares for these events, we've caught up with some of the leading figures in the field today and asked them to share their views on the history of spatial structures, the influence of digital development over the past decades, and the pioneers of this discipline that they most admire. Spatial structures have been around for a long time, in some form or other, and there's probably no single definition of what a spatial structure is, but they do have certain things in common. Jerry Park, Emeritus Professor of Structural Engineering at the University of Surrey, has this explanation.
Spatial structure is really a structure which is working in 3 dimensions. A conventional building like a reinforced concrete office block will span in one direction, and then you've got some sort of cross spans. But a spatial structure works in 3 dimensions, and it can be very wide-ranging. It can be made of sort of tubular members where you'll form in triangles which are very stiff, or at the other extreme you can have a membrane structure, which is where you stretch a piece of material. So it's a big category. There's lots of things which fall under that classification.
Haris Gantas, Professor at the Institute of Steel Structures, National Technical University of Athens, and Editor-in-Chief of the Journal of ISS, has a slightly different definition.
To define what a spatial structure is for a non-expert is not very easy, but I'll try to say it as simply as possible. As the word indicates, these are structures in space. One could argue that all structures are in space, so all of them are spatial structures. In engineering, there are structures whose the behavior can be described by simple plane approximations, so we would not classify those as spatial structures, but structures that behave in such a way that their spatial geometry, their 3D geometry must be taken into account. Those would be classified as such. A dome is a typical example, or a slab, or a cable net, for example.
So how and where did the field of spatial structures begin? Of course, the formation and development of the International Association for Shell and Spatial Structures, ISS, has played an integral role in the evolution of the field itself. Here, Carlos Lazaro, Associate Professor at the Universitat Politécnica de la Valencia and co-chair of the 2019 International Association for Shell and Spatial Structures Symposium, tells us a bit about the beginnings of the association.
The International Association for Shell and Spatial Structures was founded by perhaps the most famous Spanish engineer in the 20th century, and I would say in the history, who was Eduardo Torroja. And Torroja was a very special person in Spain. He was a civil engineer, and he had a strong background in mathematics because his father was a professor of mathematics and geometry. And he started very young to design shells, because shells were developing very fast in Germany. But he learned what the German masters was doing, and not only applied it here to several projects, but it was a breakthrough, big step forward what he did in Spain. And when he was already, let's say, not so young, he had a very good name internationally, which at that time in Spain was very rare, because it was the time after the Civil War with Franco, and Spain was a rather closed country. And he was like kind of an ambassador, and had a very good name, and he attracted many professionals to a Congress on shell structures in 1959, which at that time was the top interest in the technical and scientific community. And that was the start of the IASS, the International Association for Shell and Spatial Structures. Since then, because the initial name of the association was International Association for Shell Structures, around 10 years later, the scope was extended also to encompass spatial structures. And there was a tradition, non-written one, to celebrate every 10 years the symposium in Spain. At the beginning it was in Madrid because Torroja was the head of the Central Laboratory for Structures of the ministry. And that was the tradition, and it was kept till today because we are also celebrating this time in 2019 in Spain, in Barcelona. And it's fair to say that the association has also tried to keep updated regarding to the topics, because this initial focus on shells has evolved to incorporate many new kinds of structures.
In universities, the beginnings of spatial structures as an area of research and education often began with one key figure. At the University of Surrey, this was the late Professor Szymon Makowski. Hojsynushin, now Emeritus Professor of Spatial Structures at Surrey, was lucky enough to undertake his PhD under the supervision of Professor Makowski in the 1960s.
Well, it all began when in 1962, Professor Szymon Makowski became the head of the Department of Civil Engineering. Professor Makowski was a famous, internationally famous expert in the field of spatial structures. When he became the head of the department, he actually created a research center with the purpose of concentrating on the ideas of spatial structures. Well, the aims of the research center were any activity that helped enhancing the knowledge of spatial structures and encouraging the practical use of them. The center actually has a number of activities. Teaching. We had a number of teaching courses at different levels, different durations, which we were offering to various universities in the UK and the University of Surrey as well, and any other universities around the world. Another important activity of the center was helping the industry in the design of innovative space structures or spatial structures.
Another great pioneer of spatial structures during the same era as Szymon Makowski was Frei Otto, a German architect and structural engineer who became known for his lightweight tensile and membrane structures, such as the roof of the 1972 Munich Olympic Arena. Juan Gerardo Olivia Salinas, an architect and professor within the University of Mexico's Faculty of Architecture, recalls his days working with Frei Otto.
I started with this when I was a student of architecture in the 1970s. I was impressed of seeing the works from Professor Frei Otto in Germany mainly. Then I got a scholarship from the DAAD, Deutsche Akademische Austauschdienst, and I was able to travel to Germany and to work with Professor Frei Otto and other people in the University of Stuttgart. And the more I knew about this kind of structures, the more interest I won with this in this area. He worked mainly with models, physical models, and I wanted to work with computers. Frei Otto told me at the beginning, I do not work with computers in my institute, his famous Institute for Lightweight Structures. So you have to go elsewhere to work, and after 1 year, if you still have a scholarship and you still want to do it, maybe you can work with me. 1 year later, I came back and he accepted me. And I did a few models with him. And he's one of the tutors of my doctor work in Germany. My doctor work is called about the building of grid shells. And I had the opportunity of learning many things about the design and conception and design and construction of lightweight structures, membrane, grid shells, and many other kinds of structure. It was a great experience. I thank Professor Otto for having given me this opportunity of working in his famous institute.
Chris Williams, professor at Chalmers University of Technology in Gothenburg, Sweden, also got the opportunity to work with Fray Otto early on in his career.
And I was lucky enough to work with Ian Liddell on the Multihalle in Mannheim, Fray Otto's grid shell. And that was obviously a very exciting time. My role was to do the buckling analysis, which meant using computers, which of course in those days meant some massive great mainframe where you spent a month's salary, if you like, doing one analysis, which would run overnight and had to have a very, very coarse mesh. So I think we had something like a 5-meter mesh, whereas the real structure is 0.5-meter mesh. And obviously today, even on the cheapest laptop, you could run a 0.5-meter mesh.
For Carlos Lazaro, the chance to work on the last shell structure designed by Felix Candela was the point at which his fascination with spatial structures began.
He was one of the persons who built many shells in America, and his last shell that he conceived, because he didn't develop the structural design, was placed in my city, in Valencia, and I did this structural design together with my colleague, and that was my close relation to shell structures. From that point on, I never. So my mind was in that field.
So when did spatial structures first appear? While the work of pioneers such as Felix Candela and Fray Otto in the mid-20th century spring to mind, you could argue that the history of the discipline dates much further back, over many centuries or even millennia. Haris Gantas, professor at the Institute of Steel Structures, National Technical University of Athens, talks about the earlier spatial structures.
Coming from Greece, I would say that in ancient Greece there were some first examples of spatial structures, like arches, for example. You know, the material they were using at that time was masonry, stones. So they had to use shapes that were good, that would cause compression, in which masonry is a good material but no tension. This is what led to arches. So that's why in ancient Greece and ancient Rome we can find many arches. But if we want to look at the modern history of spatial structures, I would say that around 1940 or 45, I'm not sure when the Mero system was developed. This was a system to make joints to connect two steel bars to each other, and I think this was an important step in the development of space trusses, space frames.
Jerry Park agrees that spatial structures have been around almost since man started to build.
Spatial structures, space structures covers a big area. I would imagine that really the first primitive structures are spatial structures. So, for example, probably the Chinese people were the first to use structures, for nomadic people when they build a tent. That's a spatial structure. The American Indians and their teepees, that's a spatial structure. And it's sort of gone on from there. And then the industrial space structures around about the about 1850, the Germans started to build iron structures, so there were iron roofs. And then Alexander Bell in the early 1900s started to look in great detail in triangular lattice structures because he was trying to get stiff structures for aircraft design. So there you want maximum stiffness, minimum weight. And it's just grown and mushroomed from there, really. So it's difficult to say where it really started, but probably in China, I would say.
Since what we think of as modern spatial structures began to appear in the mid-20th century, their popularity has been influenced by trends in design. Sigrid Adriansens, Associate Professor at Princeton University's Department of Civil and Environmental Engineering, explains how this has happened and why she believes spatial structures have a bright future ahead of them.
So, initially, shell and spatial structures were really brought into the realm of civil engineering for very utilitarian reasons, right? So just for hangars or large span train roofs over train stations. Then there was a period in the 60s when these kind of systems were thought as having great architectural potential. So we see at world fairs very iconic structures that are spatial structures, pneumatic structures, shell structures, and so a lot of architects at that time embraced them because they potentially have very large formal and visual language, which was very appealing in the 60s and the 70s. And then there were some decades where, from an architectural perspective, this style was really not desired, and we went to the kind of everything being very minimalist and everything being right angles. And right now, again, there is an increased interest in this kind of organic looking spatial structures. So, they're all out there on the architectural field. But also, I think more if you take away, the visual, but if you look at how they perform, I think they have great potential just beyond, being roofs. These kind of systems have great potential, I think, at resisting very large loads. So, for example, there are some very beautiful thin curved shell dams, so they're very good at resisting water. They have great potential in resisting earthquakes. We are looking at the moment at pneumatics and how they can resist storm surges, so they could be storm surge barriers. So I think these systems one has to look at how well they perform and what they can do to solve some of the challenges that we're facing in the 21st century. So I think they have a bright future ahead, independent of whether they're architecturally in vogue or not.
One factor has influenced spatial structures more than any other over the past 60 years: digital development. Emeritus Professor Nushin at the University of Surrey was an early leader in the computerization of spatial structure design, having originated the concept of Formex algebra in the 1960s.
Well, the principal topic of research in the Spatial Structure Research Center was computer-aided analysis and design of spatial structures. In particular, our attention was focused on configuration processing, which is the branch of knowledge dealing with generation and processing of geometric forms, geometric configurations. In particular, of course, our interest was related to spatial structures. In that relation, actually a new algebra was invented called Formex algebra, together with an associated programming language, a programming system that helped generating and processing structural forms. These ideas could be of great help to industry and also to students, starting from primary schools to universities.
René Mautreau, Emeritus Professor at the University of Montpellier, remembers working with Professor Nushin in these exciting early days.
I visit the Space Structure Center in Guildford, and we define with Ocean Museum the way to begin this work based on geometry. I had many discussions with him, but what I have to say about OSHA is aptitude to develop so-called Formian from X-algebra and his digital aspect Formian. This is quite different. And this, what I learned with him is not only geometry, but a way of working, a way of exchange with other people, a way of always questioning the words again and again in order to be closest to the truth of what he said.
Another pioneer of digital tools back in the 1980s was Juan Gerardo Olivia Salinas, a professor within the Faculty of Architecture at the University of Mexico.
I wrote by myself a program when I was studying in Germany. At that time, I wrote it in Fortran 4. Fortran 4, for many people, they have never heard about that. It was a programmations language, and that was amazing for me at that time. And I'm talking about 35 years ago. So there is a development from 1980 to this year, and it is important to know what the new digital tools can help, how they can help, and they are very important, and the students have to know how to manage them.
Digital tools have undergone a rapid evolution since these early days. Carlos Lazaro describes what he sees as their impact on the spatial structures discipline.
Digital tools mean a revolution in the field because they allow to very rapidly draw, of course, in a computer, things that 20, 30 years ago, doing it by hand would have been impossible or would have taken months and with no possibility to iterate or try different possibilities. And with digital tools, I think they have benefited mostly architects because they have given them the possibility to experiment with shape. There is this is a strong research area, how to connect digital tools, geometrical tools with mechanical tools in order for the result to be meaningful. But because the risk of digital tools is that you can imagine crazy things, but then these things are difficult to transport to real built structures. But the association, the IASS, in this respect, is one of the cores where research is being carried out in order to get the best from digital tools.
Olivier Bavrel, professor at the École de Pontparétec and co-editor of the International Journal of Space Structures, says it's the affordability of these tools which is now enabling them to be widely used.
For me, the development of spatial structures is directly coming from the development of the tools that are available. You see, up to 10 years ago, new parametric tools were not affordable or they were not existing. And the capacity to represent things and represent complex geometry was really difficult, and therefore people were using not so much these space structures. They were more. It was much easier to take conventional structures. But with this not revolution, but important evolution of the tools, then any architecture student, designer, or structural engineer can take these tools and dare to do complex geometry and attempt to master this complex geometry. But at least it's not so difficult to go from the drawing, parametric drawings, to the fabrication with all the numerical tools we have. So that has been an extremely important evolution in the last 15 years. And I think it will grow up again and even more.
As Carlos Lazaro and Juan Gerardo Olivia Salinas have mentioned, the management of digital tools and the way engineering students are taught to use them is becoming an important focus. Sigrid Adriansens outlines what she sees as the drawbacks of relying on digital tools.
All young people that are being currently trained or that are being educated at higher institutions are learning how to use these tools. However, they do not take courses in, for example, shell and spatial structures on understanding intuitively or from an analytical perspective or a physical perspective how these systems work. So they can produce them, they can analyze them, but they might not really know what to look for because they haven't got the background knowledge to understand what the mechanics are in these kind of systems. And I think that's where we are today.
IES 2020 will take place at the University of Surrey in August 2020, which will coincide with the 7th conference on spatial structures to be hosted at the university. Let's hear from Professor Hoyshen Nushin as he talks a little bit about the history of this conference series.
Well, the first international conference was held in 1966, September 1966. It brought to the university several hundred experts from all over the world. Then, at intervals of 9 years, another 5 international conferences were held. The exhibition of the first conference in 1966, the Times newspaper had an article describing that. In relation to some of the conferences, the university received gifts from the industry. For example, in relation to the third international conference in 1984, the British Aluminium Company donated to the university, gave as a gift to the university, the aluminium dome which is near the lake in the university campus.
Emeritus Professor Jerry Park of the University of Surrey remembers this particular conference very well.
Probably the one that I started to become most involved with was in 1984, where we had a great team at the University of Surrey. And I remember I was in charge of the exhibition there. And I don't remember the guy's name, but he turned up with a tube. So the tube was about 150 millimetres diameter, 4 inches, and about 1 metre tall. He unscrewed the top of the tube and he emptied it out, and there was this bundle of thin steel tubes again, which were all interconnected. And he stretched this out in both directions on the floor. He got a big circle, about 6 metres diameter. And then he got under this and worked his way to the middle and started to push it up. And up came this dome. Very impressive. And then he got the centre node and he just gave it a push, went like that, and the whole thing snapped into position, like an umbrella, became stressed. And that was it, all put in this tube. And then when he wanted to put it away again, he just pulled on this node and then pulled it all slowly down and folded it all up and put it back in the tube. And I remember thinking, wow, this is really impressive. And it was a good exhibit for the exhibition. So that's still stuck in my mind. That's a long time ago.
One of the highlights of the International Conference on Spatial Structures at Surrey is the Pioneers Award, which is presented to an individual who has made an exceptional contribution to the field. Harris Gontas remembers 3 past winners he has personally been involved in working with over the years.
One is Massimo Maiovieschi, Italian professor, and designer of very well-known large-span steel structures. And I had the opportunity to cooperate with him once, around 10 years ago, for the design of the roof for a football stadium in Athens. and I was really amazed by the way in which he approaches design from all points of view, starting from conception to the latest detail. So this is one person that has made a very, very positive impression to me. And then there are two other people who received this award who are from the deployable structures community, in which is how I started my involvement with spatial structures and IASS. One is the late Felix Escric. He was a Spanish architect and engineer, a pioneer of deployable structures, and one of the few who actually has made some of them for real architectural applications. One of them is a swimming pool in Sevilla in southern Spain, and many years ago he actually showed it to me. Very, very nice structure. The other person from the deployable structures community is Sergio Pellegrino. He is now the president of IASS, and he had founded and was running a laboratory of deployable structures at the University of Cambridge in England, which I had visited a long time ago for 2 or 3 occasions. So these are 3 people I would like to mention with whom I'm personally acquainted, and I have a very, very high opinion of them.
The engineers and architects we have heard from in this podcast are among the most influential in the world today, and have worked on a diverse range of groundbreaking projects. But what are the spatial structures which have inspired them the most? Sigrid Adriaansens describes one which will be familiar to many people.
A grid shell structure that I really admire is the cupola over the courtyard of the British Museum in London. I really like it because first of all, it looks really gorgeous. It's a very interesting pattern, but I think it was also the first of its kind at the time. And since then, there have been many glass grid shells being designed and built like that up to this day, including the Dutch Marine Museum, on which I worked as well. But I think the cupola over the courtyard of the British Museum is really amazing. And even people who are not trained as engineers or architects, when they go there, they're just amazed by the spatial quality that it creates, the quality of the lighting that it brings in.
Sigrid explains why she thinks the glass grid shell at the Dutch Maritime Museum is so successful.
I think spatial structure is very successful when people come to it, not so much because they have to be there, but because they want to be there. And so for the cupola of the Dutch Marine Museum, you have free access, and the people that guard the museum say that at lunchtime people come there to eat their sandwiches. So they choose to come and sit underneath the cupola and enjoy the space. And then I think you have a really successful structure.
For Carlos Lazaro, the innovative work of Mamoru Kawaguchi, who pioneered a completely new style of spatial structure, has stuck in his mind.
Mamoru Kawaguchi, who was the president of the IASS 2 times, and was an exceptional designer of structures and inventor of construction systems. And he designed, was one of the first persons in the world who was able to design and build inflatable structures, for example, which were temporary structures, but open the imagination to making this possible. And we are speaking about the 1960s and 1970s, so it was quite a long time ago, but this has left a very important footprint.
Harris Guntus talks about another iconic and unusual structure.
There is one structure that impressed me very much. It's the Tokyo International Forum. It's a building in downtown Tokyo serving exhibition purposes. And what is the reason why this structure impressed me is that it's exposed. I mean, you can see the structure, and the roof structure has the shape of the skeleton of a fish, and everything is suspended from the fish skeleton. And as I said, the structure is visible, so it's possible to imagine the flow of forces through the members, and this is a project that impressed me a lot.
For Chris Williams, the Munich Olympic Stadium, designed by Frei Otto, is the spatial structure which has left the biggest impression.
And I remember a few years ago going to BMW Welt, which is just across the way from the Munich Olympic Stadium. It's got massive steel space frame structures in there. I mean, really chunky. It's massive. It's sort of a bit like a cathedral, because it's got these sort of side chapels. With BMW 1 Series, you go and worship the 1 Series, then you go and worship the 2 Series, and then it's a real sort of cathedral to consumerism and massive use of resources. And then you go across the way and you come to the Olympic Stadium, and it's like, having a sorbet after eating some, massive meal. So it is, I think, still now very, very impressive. And probably even if you weren't an engineer or an architect or whatever, never heard of Frei Otto, you would still go there and say, wow. And that's very important, of course, because we're not just building for people who are sort of know about these things, we're building for ordinary people.
These iconic structures demonstrate the range and scope of the discipline, and its ability to inspire the people who create them and those who visit and use them. In this podcast, we've tried to give a snapshot of the history of spatial structures, from the earliest examples many centuries ago, through to the first modern spatial structures of the 1950s, to the innovative structures being pioneered today. In our next podcast on spatial structures, you can hear our experts' views on the future of spatial structures and how they believe new technologies and techniques will shape the discipline. I'm Mark Richardson from the University of Surrey, and I'd like to say thank you to all of the experts around the world who contributed to these podcasts. Thank you for listening.